Okay, welcome everyone. I'm Brian Wang. So let me first introduce the group Monte Jade that is hosting this event. I'm on the board of Monte Jade. So the talk is about the new space age where the impossible is possible. So it's a webinar format. It'll be a 30-40 minute talk by myself, and then we will have question and answers. So if you want to put in questions, please use the chat feature. And then when you're called, you can unmute yourself and then ask your question, and I will answer it. Monte Jade West has been around since 1989 and building communities. So having connecting Asia with Silicon Valley and with Asian Americans. So we have an interview series events that people meet in person for events. There's technology forums, again, with often have panels, in-person events, network socials, and then there's a mentorship program where professionals can get mentored by more senior executives on how to advance their careers, professional careers. And about 30 plus events annually and about 2,000 plus members. And then you have the website, montejade.org. So Monte Jade's founding members, things are written in Chinese. Unfortunately, I'm born in Canada and can't read them, but there's many famous people who were part of founding this, including Terry Gao, CEO of Foxconn, and other noted luminaries from that 1989 period. And there's still many other very accomplished people on the board. And there's a mentorship program which is sponsored by the various these companies that you see in Silicon Valley. And there's also an executive sponsorship program that people can contact Helen at montejade@gmail.com to support the work that we do, including TSMC, EMC, and many other companies that you see here. And we'll do other webinars. So let me just switch my slides over to my talk. Okay, so people will know that there was the catch of the SpaceX Starship, and that was an amazing sight to see. Some say it rivals Neil Armstrong landing on the moon in terms of the amazing shock that it provided to the world. What they don't realize is that this really kicks off the true space age, and that we will have 1,000,000 times more capability by certain metrics, which I'll discuss later, based on what's going to be happening with it, which I'll explain. So I'm Brian Wang. I'm a fundraiser. I'm also putting together a fund of funds. I'm an advisor to a very interesting startup, Sidereus Space. I won't necessarily be talking about them this event, but the Q&A you can ask, I can describe them briefly. I'm also a personal investor in SpaceX via SPVs, which is a special purpose vehicle. Again, we can ask about that later. I did some work with Airbus Ventures before, where I went through their portfolio of companies to help them do some stuff managing those companies. So been deeply involved in looking at satellite technology, ride-sharing technology. So I've looked in detail at that. I've written over 30,000 articles on my website, Next Big Future, and on my YouTube channel. I published things on Twitter. So those 30,000 articles, about 8,000 of those are on space and space-related topics. So now I'll discuss the space disruption. The sections of the talk are here. So first, I'm going to talk with what's happening now. So what makes money in space now? Although everyone looks at the rocket launches, actually that doesn't make most of the money. That's overall $300-400 billion of an industry per year. The vast majority of that is like things like TV and entertainment. Direct TV, even though most people don't use satellite TV anymore, with 27 million customers at 1.40 million customers, that was a company valued at $40 billion. So those kind of things, getting information from space used by people on Earth is the primary value of the space industry. And also you have internet, you can get satellite internet from Starlink, also from HughesNet, other companies. And then we've spent a lot of money on spy satellites and Earth observation, both for military and for commercial purposes. Again, you're using the fact that you're putting them in space, either a geosynchronous orbit or low Earth orbit, to look at things on the ground. It is a high useful thing that we spend a lot of money upon. Actually, NASA, whenever people think, oh, NASA has such a big budget, more budget for the military and for spy agencies. Combine that together, it's probably about 2, 3 times the budget of NASA. And then there's a lot of stuff in ground receiving and then GPS, which everyone uses in their cars, etc. This is a little infographic describing the whole industry. Main talking points are that it's revenues for satellite services, ground equipment, and are the main things, 110, $150 billion. The other stuff, satellite manufacturing, launch industry, are far, far smaller. So now discuss the current state of the situation. The SpaceX Falcon 9, which launches about 20 some tons to space, has delivered 90% of the payload into space this year. That means the 10% that they didn't do includes minor players like the country of China and the country of Russia. So they got squeezed down to practically nothing because SpaceX is launching 100, maybe 140 times. This year they launched nearly 100 times last year, which is a huge jump from prior levels. And also of the satellites, 65% of the active satellites over the Earth now are Starlink satellites. So and launching on the order of 3,000 per year, which in 1 year they launch more than all the other satellites that everyone has put up and still up there after decades of launches. In low Earth orbit, the domination is even more severe. 20 times the satellites that were around in 2018, so less than 300, you can see on this chart from Nature. And then 2019 is when Starlink started launching. And this is going to 4,500, it's actually up to about 7,000 there. And then most of the other launches increased where other satellites increased to 1,000. Most of those other commercial launches were made by SpaceX. So the domination is extreme. So the Starship shock. So this is the preamble to Starship coming along. So they already have domination by SpaceX, and that's going to get even more active. So this is just a rendering of that catch from Flight 5, and then Flight 6 is going to be going up within 2 weeks. So in space, this is a chart from McKinsey. If you go back to 2022, you can see that less than 3,000 tons got put into orbit that year. So, and then they have some projections, which I don't think are correct, about what will happen with Starship. But they did talk about 42,000 approved satellites, which will be rapidly launched over the next 2 years once we have Starship fully working. But you just keep in mind 3,000 tons in 2022. So when I say 1 million times, the world had about 40,000 big planes. You know, the Airbus 380, the Boeing 787. Those planes cost about $300 million. And the world uses about 40,000 for all the commercial passenger planes and for all the air cargo and for military cargo, roughly, ballpark. So what if we can make 30,000 Starships? It would actually be far cheaper to make 30,000 Starships than the cost that we spent for the 40,000 big planes. $900 million at $30 million a piece versus on the order of $300 million a piece for the big planes at $10 trillion over many years. You know, you make about 1,000 planes a year from Airbus and Boeing each, so about 2,000 planes a year are made. So over 20 years, you make all those planes. The Starship will be fully reusable, which means you can launch it 100 times a year, twice a week. Each one could fly that much to orbit. It can fly more often point to point on Earth. So that would be ballpark 3 million flights. That could launch 600 million tons to each year. I remember before we were talking about 3,000 tons in 2022. Thus, you're getting, 2 million times more. Um, so this was the pictures of the actual catch for people who missed it. And this is catching something that is, you know, 20, 30 stories tall, right? It's a really huge thing. The launch tower is about 440, 500 feet tall. And the launch tower itself is amazing, beside the fact that it has arms that can catch things. In some ways, it's like a stationary robot that is like a giant, those Pacific Rim or other Japanese super robots catching something. It's catching something that weighs 700 tons if there's still a lot of fuel left in it. Um, so an amazing compliment. And before I leave that, probably only cost less than $100 million. The um, other NASA launch towers, Slick 40, there's about several dozen of them. They cost on the order of $4 billion. So this is going to go mass production, which I'll discuss even more, that you need launch towers, um, much like you need runways for airplanes. So Starship, again, 10 times the payload and then 10 times maybe more for the launch rate, which is key to how much you can put up into space. The engines are another amazing thing. So we up to Raptor version 3, and this thing is slightly taller than a person. Again, roughly the size of a car. So we'll come back to that point. So SpaceX had the factory for Raptor engines that at full production would make on the order of 4,000, 5,000 engines per year. That would be enough for 100 for the 40 engines that need to go into a super heavy Starship, the top stage and the bottom stage. The improved engines mean that you get, on the second to the bottom line, increasing amounts of reusable payload, 240 tons potentially for a slightly more advanced Raptor's range. And we already should be at 220 once they make the Starship, fully productionized without extra redundant weight for certain things in their prototype phase. And then expendable payload in the middle column there, 400 tons, and then all these thrust levels. When you combine the 33 engines that are on the bottom of the booster, it's already double the power of the Saturn V rocket that took the astronauts to the moon. And with the more advanced engine, it will have triple the power of the Saturn V rocket. Even the upper stage, if you had 9 engines instead of 6, you'd be on the order of the power of a Saturn V bottom booster stage. And these engines are super cheap. They only cost, on getting down to cost, about $250,000. Maybe at $500,000. They haven't given us full details, but they can't. Their goal is to get them down to about $250,000 per engine. So the price of an expensive car, like a fancy Porsche or something, or like a Tesla Roadster, $250,000. So 33 engines at that cost, $9 million for the booster stage for engines. Double the price, and the whole booster might only cost $20 million. $10 million for outer stage, $20 million for the booster. Again, these costs are important because you're bringing the cost of space way down. The cost of the engine, one engine that was used for launching the space shuttle, which is still being used for the space launch system that is being used by Lockheed, that cost $100 million. So the cost of one engine in the old system costs more than the entire Starship, the Super Heavy Starship vehicle with 40 engines. So just we're totally redefining the cost structure and the usability of the engine and the launch towers and everything else. So 6 engines for the Starship upper stage would be $2 million. So you can get these costs way down. And so I'll come back to that. So double the triple cost for the final cost, because just as a financial cost estimate, you can just double the triple the cost. Say beyond the engines, how much does the metal shell and other electronic components cost? And it's mostly empty fuel tanks. So 100 uses at $30 million means that the per use capital cost drops to $300,000. And then $1 to $2 million for the fuel and the maintenance if you have full usability. So again, what was a, say, $1 billion, $2 billion throwaway rocket that Space Launch System or Apollo would try to do, now you're looking at 1.5, $2.5 million of cost per launch because you're not throwing any of the rocket away. So you're bringing the cost down by maybe 1,000 times from the $2.5 billion rockets from that Space Launch System, from United Launch Alliance, or from the old Apollo systems. And again, it's less than the cost of a big plane. A big plane, a 787, Airbus 380, they cost $300 million, $350 million. Now we're looking at $30 million when these things get to full production. Even now, they may only be $100 million. So way, way cheaper. And the usability will increase up to this 100 times, maybe more for each rocket before you have to replace it or make a remap. So how do we change the world? It's 30 times faster. By going to orbit, you're going 26 times, 27 times the speed of sound, 30 times faster than a subsonic plane, your 600-mile-per-hour plane, 10 times cheaper than the plane, 2 to 10 times the payload of the plane. So a 747, the old style plane, jumbo jets, would only have 80 tons of payload max. Maybe you have some military version that can get to 120 tons. And you can fly further around the world with just the Starship. With just the upper stage, not the 2 stages that need to get to orbit, you could fly pretty much anywhere in the world, 8,000 miles. So further than a long-range 787. And you'd fly there in like 30 minutes or something. So now we talked about the Starship. Now we talk to what do you do with it? Because I said the rocket part is what enables it to do it, but the satellites is what makes the money. So beyond cell towers. Cell towers, there are about 5 million cell towers in the world. They cost on the order of $150,000 to $1 million each. And then you have to rent the, mountaintop or poles on some property for $30,000 to $200,000 per year. And then you have to replace them. But if you replace them with satellites, then maybe 1-to-1 or 10-to-1, then if you can get that cost down there, then you could fully replace cell towers. The satellites, and talk to Starlinks, are somewhat like the size of an electric car, 1 to 2 tons for Starlink satellites currently. And then the bus-sized satellites are the ones that go to geosynchronous orbit, but SpaceX could also launch larger versions of that. The size and complexity is similar. So if they're that complexity and they're that cost, making 1 million of them, which Tesla makes 2 million electric cars per year, and the world has 2 billion cars total. So if you were to say electric cars could replace all cars and get to 2 billion, then it's not inconceivable that you could make millions of satellites per year and then get to a total of 1 billion or 2 billion satellites. When you're still at the scale of replacing these other traditional things that cell towers that you're replacing with satellites. So these pictures show the stack of satellites from different versions of Starlink, 1.5 up to a later version now called Gen 3. This table is slightly out of date in that they were talking about launching 50 units of these satellites that weigh about 2 tons each, and the far right table. That's when we thought the Starship might only take 100 tons to orbit. Now we're talking about 200 tons, so you can then increase the number of now called Gen 3 satellites each launch up to 100. And also the gigabits per second per satellite, they were talking about getting just under 3 times improvement from what's called the version 2 mini, of which there are a couple thousand of those up there now, going from 60 gigabits per second up to 170. Now they're talking about getting 10 times more bandwidth. So getting up to 600 gigabits per second, maybe a terabit per second. And they're constantly improving that, using more bands, which is, technical aspects of frequency and stuff like that to get even more. So these constant improvement is what's happening with these Starlink satellites. Starlink costs the version 1 satellite is $200,000 and then $150,000 per launch based on how many you can launch per rocket launch. And then version 2 minis, the one that are currently being used, about $800,000 with $300,000 per launch. And then the next generation version 3, when they're launched by Starship, will be about $1.2 million and they'll be down to $30,000 per launch. So again, these costs are not dissimilar from what's the cell tower cost. And then version 3 will have 10 times the bandwidth. They'll move closer. Right now, they're about 50 times closer than the geosynchronous satellites. Geosynchronous is 25,000 miles away. These are currently about 400 miles away. And then they're going to get even closer down to about 300 kilometers, about 200 miles away with new FAA links. When you get closer, you can communicate faster for different purposes, either with direct to internet or with direct to cell phone communications. And the costs, again, transformative, like 100 times less than the $100 million plus for the large geosynchronous bus size satellites. Other makers, CZ Astro, I interviewed the CEO a few years ago for that Airbus contract, Airbus Ventures contract I mentioned, and they make low cost, low Earth orbit satellites as well. But SpaceX just has bigger factories. There's also innovation on the receivers to receive Starlink. They have mobile versions, costing as little as $50 per month, and they use less energy. So if you 25 watts instead of 100 watts for that, and then still have comparable communication speeds. When they get the Gen 3 satellites up, the communication speeds will increase by about 10 times for individuals. And they can bring them anywhere. You know, say a person can carry on the backpack about the size of a laptop. And then this could be further innovations around the receiving systems of this, where maybe I could do one with 10 megabits per second with something the size of my cell phone or something like that, you know, where I could merge that in. So that it blurs between just cell phone communication or a high-speed internet. And they'll launch these larger version Gen 3 satellites, like a Pez dispenser coming out of the large Starship rocket. When they unfold, so they're deploying folded up, they then unfold like an accordion or something like that. And then it would look like the size of this compared to the International Space Station or compared to a football field. So the Gen 2 Mini is about 116 square meters unfolded. Gen 3 will be about 480 square meters. And they could make further improvements because space is changing all the time. The International Space Station has about 2,500 square meters of solar panels. And here I have it kind of with the green showing against the International Space Station behind the SpaceX supersized satellites thing. So then if I launch 100 or 120 of these satellites at one time, then it would cover on the order of 12 football fields worth of solar and satellite receivers. So the size of it is hugely important because during the recent hurricanes, they turned on Starlink for direct to cell phone communications. So they transmitted millions of text messages already for that emergency service. When the phone lines were down on the ground because of the hurricanes, both in North Carolina and in Florida, and tens of thousands of people use the system already. And the speed to communicate directly to cell phones will increase. The bigger you make the satellite up top, the faster you can communicate without changing the system down below. And also by making them closer or using other bandwidth, you can also increase the speed. And then if you were to modify your cell phone to have some kind of in your phone holder, perhaps an antenna specifically to talk to the satellite, you could then further, again, increase the speed by a lot. They have a large dome-shaped receiver for communications to the satellite to get up to 10 gigabits per speed. So you can have really, really fast communications. Thus for business and military communications. So like I said, Gen 3, make it closer, bigger, increase from 30 megabits per second for a single communication up to 300 megabits per second or gigabits per second, which means I could have, say, 10 kilobit per second communication for um, 30,000 cell phones or 100,000 cell phones when one satellite is overhead. So it goes to how fast you can communicate. When you have that large fleet of satellites up there, and they'll increase them very quickly with Starship, then you can go to maybe 2G communications everywhere, 10 kilobit communications, text, voice, internet. I mean, no dead zones. Um, that kind of speed, 2G, is about what you get when you have T-Mobile and go to other countries that you're not um, don't have your main service in. So it's a highly useful level of capability. Starlink currently this year makes about $10 billion per year. That's with 4 to 5 million customers. The limitation for them is not necessarily the satellites currently, the most near-term limitation. It is getting enough of the dishes deployed and sold to people and get them, the customers, more evenly distributed around the world. Right now, a lot of customers, 80% perhaps, are in the United States, which then means that the current fleet of 7,000 satellites, only 3% are over the United States at any one time. Um, I'll show that later. So that means that if you had customers in Europe, um, Asia, South America, Africa, you could, get more service. If you got customers that were spread out in other locations, because the service of satellites is more evenly spread, so you can't concentrate up to provide service as well for cities. So I'm expecting this revenue for SpaceX to increase to Starlink $40 billion per year in 2025, $100 billion per year in 2026. And this will go from barely profitable now because their total costs are about $8 billion. The cost will barely increase as they uh, increase this revenue. And then that will make them a multi-trillion dollar company because you would have a PE of a fast growing company of 50 to 100. So then if you have $100 million of nearly all profit, then a $10 trillion valuation would not be unreasonable. And I expect them to get to about have a terminal point of about 30% of all cell phone, internet, high-speed internet communications. They will work with their partners, like AT&T or T-Mobile or all these other phone companies and national phone companies, and share the revenue with them because of the geopolitical and other reasons. So they're not going to put them out of business. They'll work with them to provide a service. The value they provide is half of the capex for cell towers would go away. All the remote cell towers would not be used. You would then be able to just use the satellites. So then further improvements on bandwidth, beamforming, there's other ways to improve it. Technical details that we don't need to go to here. Something else that's being used is I just announced today was that SpaceX will make Mars Link, a communication system over to Mars. Elon said that this will be just the beginning and it will ultimately go from 4 megabits per second up to about petabits per second. So megabits, gigabits, terabits, petabits. So about a billion times faster communication to Mars, between Mars and Earth. Okay, I can talk a lot more about that. I have a detailed analysis of that in other reports. But now I'm going to describe that the Starship is actually beyond nuclear weapons. So it's not that I'm pro-military like that, but it's that the change is this thing is so capable that nuclear war is basically passe. We can go beyond nuclear war. We don't need to bother thinking about that because we'll have this other capability. And I would argue that that is a good thing because having the US completely dominant with Starship means there's nothing like World War II where Japan and Germany thought they could beat the United States and the other Western European countries, and that was a mistake. If they knew we have no chance, the war doesn't start. So that's the military analysis. So let's compare it to a B-52, an old plane, but still the main bomber for the United States. So a B-52 or B-1 bomber, they have about 30 to 35 tons worth of missiles and bombs. Only the explosive part is the part that actually does the damage. So not the casing, not whatever else you're launching with the missile. A Starship can carry 200, 300 tons of payload, and it's 25 to 35 times faster. A BC-2 has roughly, say, 50 tons of TNT explosive power max, because the high explosives are about 1.6, 1.7 times better. A Starship, just releasing 200 tons of payload, just metal, inert metal, I don't have to have any explosives in it, would have the kinetic energy of 1,700, 2,400 tons worth of TNT. So, and that's like just, you're in the range of the 10 kilotons used in the Hiroshima bomb. But you can then reload. I can just reload and get more metal. So it's like I'm taking a gun and then putting a lead bullet into it, because basically it's just inert matter that I'm speeding up the energy of the fuel, turns into kinetic energy for the payload. So, and this would be, the cost would be like $3 million because of fuel maintenance and then just deadweight payload, versus 160 to $500 million to $1 billion for a nuclear weapon. And you could just reuse it. I could just like pop in more stuff if you were. So this goes to the US doesn't need to use that, because one, you don't need to mass destroy a population in a modern war, and because the um, the US capability is basically so far ahead of what from SpaceX of any potential opponent. So I would also say that, as an aside, the US already had that capability of being totally overmatching the others, but this would be um, removing any doubt and any need for anyone else to try and challenge the United States. So the deep bunker buster bombs, so it's a side, the military side again, is that Iran has a nuclear weapons program. The concern is that we cannot reach and destroy that nuclear weapons program, because the facilities that do the centrifuges and stuff like that are about 300, 400 feet underground, under a lot of hard rock that they dug into. And they also have some special cement, ultra hard cement, that makes it tough for even something as capable as this bunker buster to reach it. Um, so it's 15 tons of mass that they release, and then it hits at a high speed, about Mach 1.2, and then it gets to a certain depth, and then it blows up the explosives to try and get to a bunker. But they think it would take many strikes in order of the exact same spot in order to dig down to the 400 feet deep bunker. The payload would be, for a Starship in alternative, would be 200, 300 tons, maybe up to 20 times as much, and definitely over 14 times more weight than the bunker buster bomb, and it would hit with 20 times the speed, or 400 times, or maybe 1,000 times the kinetic energy. So if you can think of it as, I can throw a bowling ball at something, or I can fire it out of a high-speed a naval gun that would launch, a 200-ton, like far more weight than the bowling ball, and a far higher speed. So basically, it would totally reach the Iranian bunkers, Russian bunkers, or whatever. So, and what does this mean for our lives? The fact that we'll have a million times more space capability, and all these satellites that can do many things that replace the old ways of doing things. So communication, energy, location data will be everywhere. We'll be able to have ultra precise, millimeter precise GPS systems. We can have massive amounts of solar. Just the solar on 42,000 Starlink satellites, just used for communications, would be many gigawatts of power, more than a nuclear power plant combined. And if you also launch one specifically to provide space-based power, that would be even more. You get to a lot of moving the power generation up to space-based solar. And then you'll have integrating all these devices and sensors into all kinds of cars, the devices, and everything else we're using. So then businesses will have to figure out how to use all these satellites and services that will be exploding onto the market over the next year or two. Something that I can help advise in more detail, because it's a far more in-depth topic. So now I'm going to discuss that this was a lot about Earth and the financial impacts. there is a bigger future of developing the space age. We all know that Elon's working to try and make a city on Mars by about 2050, launching 1,000 starships every 2 years when the Mars gets closer. What will they do there? I believe that they will make AI data centers on Mars. So for people who don't know, the AI data centers are having huge growth. There's talk about spending $125 billion on one data center in North Dakota. And two companies are supposed to spend that much. We don't know who they are, but it's one of the top seven. It's going to be either, Microsoft, Meta, Amazon, you know, some one of those big companies is spending that kind of money. If you spend that kind of money, you can send a same capability in the many starships over to Mars, and then you would have all the land to build as much solar as you wanted, terawatts of solar. So then you can make something that would be 100 times the compute, 1,000 times, 10,000 times the compute of the systems on Earth. And then the fact that it takes 2 years, whatever, to transmit back via the Marlink network would not be, to do the training and then to send it back would not be a problem because we're spending months to do AI training now. So this, I think, aligns with something that would have, many, many billions of dollars worth of value to make a capability on Mars that could then be used for other purposes. I think having all that solar power that you generate and do many other things to build and create a colony on Mars. And this is the amount of mass they end up launching every 2 years. If you launch 1,000 starships, would be on the order of the 500,000, 700,000 tons that were landed on D-Day in World War II. All the tanks, the planes, the hundreds of thousands of soldiers that were landed on D-Days. That amount of mass is what you could put over to Mars. Just a scale of what we're doing here. I mentioned before that you can make millions and maybe even billions of satellites with mass production because they'd be on the order of the complexity of an electric car. What's something they could do to explore space? You could explore literally all the exoplanets in the galaxy, in the Milky Way galaxy. They have about 100 billion to 500 billion stars in the galaxy, and each one probably has planets. If you go out 20 times further than Pluto, you're at the gravitational landing point, where the entire sun is bending light into an Einstein ring that you can then use some computers to convert into an image. So then you could get megapixel images of all planets in the galaxy. So that's the kind of thing where we can explore things by just going 3 light days away. So far closer than all the light years to go to something else. So something where exploration could be of the galaxy would be super advanced from where we are now. And you can send them out by, again, using the sun, by taking a close pass of the sun and using a solar sail. Solar sails have been deployed. So if you go 20 times faster than the Voyager mission, and we've already gone 3 times faster or so in another mission, if you go to 60 times the distance from the Earth to the sun every year, then you can get out to this point about 20 times further than Pluto in a 10-year period. So then you can start exploring the galaxy with a lot of these bulk produced satellites with a 1 meter or so telescope. So that's basically my talk. Again, Brian Wang. So people can contact me for even more detailed than this SpaceX analysis, where I can go into all their product lines, how they'll release over the next few years. I haven't even discussed the military application, where they'll probably make several tens of billions of dollars off that. People interested in investing in SpaceX, it can be done via special purpose vehicles. You can, again, contact me and I can help you with that. Again, not financial advice. And then I have a lot of knowledge on space, deep tech, AI. I've done an AI talk and done that. And if you're interested in serious space, you can contact me. So now we're open for questions.
Thank you so much, Brian. This is Nana. I am going to try to moderate some questions right now. I don't see any questions being posted. Um, I also welcome anybody, maybe if you just wanted to ask the question directly. I don't know if Brian, you have any preference, but uh, we can also make it a question just
Yeah,
directed. Yeah.
sure.
Um, I do have a question though, just it's very, very interesting. You know, what do you think would be the business model of these space investment? What would drive, what's the main catalyst?
Well, I was saying you're providing the current business where $300 billion already being made is providing services to people on Earth, right? Because 8 billion plus people on Earth and providing things like better cell phone service, better GPS, better satellite imaging. People are already paying for that. Communicating, entertainment, those things are hugely important. Um, so other nations need to make their own communication satellites. So making a constellation of communication satellites, because you're driving the cost down so low, it's like less than $1 million potentially for a very useful satellite, and even $10 million, $100 million for hundreds of satellites. Then people need to think of like I'm mass producing satellites. Um, there will be companies that will be making all these things. So then it's like going from an age of a few mainframe computers to many PCs, right? What is
Mm,
all the software and services that you'd be doing now that um, I can have my own personal satellite if I wanted to, right? So what is the utility of doing that? Or I can have some kind of satellite as a service. There's creative ways to think about now that this capability is opened up and affordable, then what do you do with it? You could also do things like deploy computers up there that would calculate things or get, sensor data. It's again, does that answer your question?
yeah, yeah. I think the interesting thing, and I do have there's a question from Ming in the chat, but before I ask his question, I do think that it seems to me that this elevates the geopolitical war to a different level, right? I mean, the people who can afford to send these Starlinks or satellite, I mean, there's definitely uh, uh, I would say ownership issue or national security maybe concern that
Well,
could,
again, so the national security
yeah.
thing is that basically the um, United States totally wins, right? For a
Mm,
few decades, because people can say, "Oh, you can try and catch up," but the lead and the rate of innovation from SpaceX, because no one else has done a booster landing, right? And that's been
mm,
for 10 years, right? So the the US basically through SpaceX will own 99.9% of space, right? Until other countries, just like after the nuclear weapon, you can say, okay, Pakistan said we will eat dirt until we get a nuclear weapon. So you can do that too. You can say, okay, we must also get to this capability. Just like um, Boeing had the 747, and then Airbus and Europeans spent $20 billion to develop a competitive plane. Took a few decades to do it. Same kind of deal that you can develop that capability to come. But for now, for the next few decades, is be a fast adopter. Okay, you're going to launch it. I'm going to focus on the satellite, the utility that you're going to be launching super cheap things. And how do I do that? I can now have, you know, there's no reason that any place should have no communication. The billion that don't have phones or things in Africa, all that goes away because we can all have uh, this communication capability. Any rural area would have very good communication capability and also extremely good positioning, way beyond the inaccurate GPS we have now. You can have like as much as you can control a factory or a warehouse with precise communications now. I can hook up and put in sensors and say, okay, within my factory, within a lab, I know exactly where things are. I can know exactly where things are and communicate and provide power to them anywhere on the planet because I will have a million satellites overhead providing energy, pictures, video, anything I need.
yeah, yeah. So Brian, let me ask, because there are now quite a few questions. I just want to make sure, and this is similar to what I just asked from Meng.
Mm.
Can other nations close the gap in terms of space tech? I know China is a main competitor in this space. So it's almost what you're just saying. There's some sort of a first mover advantage in this because now you say US pretty much dominate. And so how can other nations close the gap?
So China's trying to develop and copy the rockets because basically SpaceX has shown what they look like. Um, so that is so they're working towards doing it. The issue with copying is that Elon and SpaceX are innovating far faster than anyone else. So catching up is a problem if you cannot move in order to catch up, you have to move faster than the leader, right? If the leader is running 10 times faster than you, then you're not catching up. Every year that passes, they're getting 10 years further ahead, right? Because he is so exceptional and the companies he makes are so exceptional, right? So that is the problem with catching up. But getting to where SpaceX was 10 years ago with a Falcon 9, that is something that a lot of other companies are getting close to. There's some Chinese companies getting close to that. So you get to that point, it's like before I make my 747, I can make my DC-3. Okay, you make your DC-3, and then you work towards making your 747, right? And then, but here's what I need to do. I need to make launch tower, the catching. I need to do, so because SpaceX is doing it out in the open, right? So you have to develop, they know the path because like, okay, they're doing it. How fast can I figure out how to do that too and copy it, right? So given what's happened up to this point, it's 10 years and they have not copied the Falcon 9, but I think maybe in the next year to three, um, there's a company called Rocket Lab in the United States that also then launches. They will have a neutron rocket that will be a Falcon 9 class. There's Blue Origin, Jeff Bezos' Amazon company that will make a Falcon Heavy competitor with a New Glenn rocket. Perhaps they have retested the engine. They could fly that. They can get into capability. China has about 10-ish companies that are working towards making a Falcon 9 rocket. They've tried to do a landing, have not achieved it yet. Again, it's what's SpaceX makes look relatively easy is just a very difficult thing to do.
Okay, well, another question from Michael Leong. What are
Mhm.
your views and how are companies like SpaceX thinking about sustainability, specifically around end of life and recycling of satellites? I
Right.
am reading reports that we are trapping ourselves on Earth with space debris and low Earth orbit, for example, the Kessler syndrome, and not having launch windows to get into deeper space or Mars.
Mhm. So because the Starship is so capable, you would be able to send some of them up that have, they open up and basically start catching and removing space debris, right? There's also other ways to use lasers to try and kind of push debris into lower orbit and have it burn up and get out of the way. Um, for Starlink has been designed to go to these low orbits where it takes a lot of fuel to keep them up there, right? So they're resisting not burning up because the closer they go, the more the atmosphere kind of increases it's still very thin, but it gets to a level where it takes more fuel to maintain the orbit. So because they're flying so low, once they stop their thrusters and say, okay, we're not going to keep it up there, then they burn up. They've already burned up 600 of those satellites because they weren't in the right orbit. And they say, better than recovering, we just destroy them because we don't need them because it's so cheap to launch them. So it is a disposable system, but disposing it easy. I just let it burn up the atmosphere.
Uh, well, I learned something about that. Okay.
Yeah.
So, while we continue to wait for other questions, how do people then mark territories in space?
Mm-hmm.
Can you mark territories, or how would you think about that? Because obviously, on Earth, you have, you know, borders, right? Um, so how do you think about how would that work in space?
So there's a bunch of United Nations agreements around how you can utilize space and who owns what. There, you have control of the airspace over your country, but we already have you know thousands of satellites. Even before Starlink, there were thousands of satellites that were overhead of countries. So there's something called the Kármán line. So about 60 miles, that's considered space, and then people have free use of orbits because you cannot really control what orbit you're in. When you're in an orbit, you're kind of like going all around the globe. So even though
Mm,
you're not like over like just over the equator, you're like making multiple passes where you don't pass over the same part of the Earth, you know, after 10 passes. It's a more complicated thing. So
mm.
um you so they don't have rules around, okay, you must avoid being, like anything over China. No, we already have satellites going over China because that's the way orbits work.
Okay, thank you.
Um,
Any other questions, anyone?
Why don't if no one else does, I can ask one of the people on the call, Doug Plata, a friend of mine who does space network development. If he has a particular question he might want to ask, if he's can unmute himself and ask something if he wants to. I think you unmute yourself, Doug. You're still muted. Can he unmute himself, or do we unmute him? Maybe I can do that. Let me just do that for him. Hang on a second. Um, I have to ask to unmute. Do we have any other questions in the chat while we're looking here?
Yeah, there's a new question from Meng. So I
Oh,
read a paper talking about using nuclear weapon in space and causing chaos.
hmm right.
What do you think about this?
Well, as I was just saying, the nuclear weapons are far weaker than what Starship's capable of. It's just speed. So something
Mm,
that people understand when they look at science fiction and all that kind of stuff is that once you get speed to orbit, 26, 30 times the speed of sound, the amount of kinetic energy is like 5 times more than chemical explosive, and it gets into the range of what nuclear weapons are capable of. If I can
mm,
go to 1% speed of light, I got way more power than any kind of nuclear weapon that you got. So when people say, oh, you should be peaceful and blah, 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 if your spaceship is going 1% speed of light, you don't need nuclear weapons. All you do is just, like, again, shove something out the door and it'll hit with the power of a nuclear weapon. So um, the more capable we are in space, the less nuclear weapons matter. The fact that we
mm,
can then go to Mars. So one thing is that when we go to Mars, if you want to make a city of like 1 million people on Mars. If I have an industry layer like AI data centers and factories building starships and other and Tesla bots on Mars, that means that you can then go anywhere in the solar system, right? If I have
mm,
thousands, tens of thousands of starships, and I'm flying to Mars, I'm flying to the moon, Saturn, you can then colonize everything. And there's a billion times more energy and raw materials in the asteroids and and beyond in the Kuiper Belt and stuff like that. There's no reason for, oh, I don't have enough steel or platinum or this or that. You'll have abundance of everything by finding Mars. And people think, oh, going to colonize Mars is the end goal for Elon's ambitions. I mean, it just means that you have gotten to the starting point where you can colonize the entire solar system and then go beyond the solar system. So basically, it gets us to space for real, right? That we
mm.
can make a Star Trek-like thing. I have detailed videos that describe what I'm talking about here with this capability. So,
I know. Yeah.
yeah.
It's scary, like how what we saw, in movies are really becoming real. Well, Jackie has a question related to Mars. I mean, if it's affordable, uh, when do you think the Mars trip will be feasible? right? And if she really wants to go, or how shall I prepare, or how should the person prepare for it?
So SpaceX is going to probably try recruiting people to go. Initially, of course, it'll be, the more exceptional astronaut type people. He's talking about 2026, the next window, to
Mm.
send several unmanned missions to Mars, and then 2028 he would send manned. Because these starships will proliferate so quickly, then each one could take, if you fully loaded them, especially on a long mission, you probably look at several dozen. Maybe eventually you look at sending 100 people per launch. If you send a fleet of 1,000, then you could send, 5,000, 10,000 people and each go. So you start thinking about, you know, applying, wanting to do it, probably around 2032, 2034, and by 2036, they would be sending large numbers to it. And likely because it's a multi-year commitment to do that, then the people who say, yes, I hands up, I want to do it, you'll probably be able to go. That the amount of people who say, I just prefer to stay on Earth might be larger. It depends what happens with automation, what happens with work, how many people then choose to want the adventure of going to Mars.
But is it like just boarding a plane, or do we have to be trained for a month in different environments, or what
There'll,
does it
there'll be
take?
training. There'll be training involved, and it's
Mm-hmm.
not like a trivial trip. Going
Mm,
one way, because the engine is so powerful, because you can refuel, you can go there on the order of 60 to 90 days one way. Um,
wow.
because it's a lot faster than the 6 to 9 months to a year of having a weaker rocket. It just has to do with orbits and stuff like that. So 69-day one way, you do not have a window to come back, really for 2 years. So you're looking at, kind of a 3-year minimum. But, if you're going to be an early colonist, they don't want to be, taking you there and taking you back for no reason. They would prefer people who would, want to stay there longer to, be a colonist.
So
Um,
it's not really for tourism yet.
it won't be for tourism yet. Tourism for the
Okay.
moon could
Yeah.
to orbit into the moon. If I have this kind of capability of being able to launch a million times more,
Mm,
they will be able to make a lot of space hotels, space other things in low Earth orbit.
mm,
Something that I can discuss in detail. And then also going to the moon is also far easier. So going to orbit will be trivial because they'd be sending thousands of ships there all the time. So going to
mm,
space, where it's like we only have like 500, 600 astronauts total over the course of 60 years, going to orbit, everyone could look at doing that within 10 years, right? If I got like 1,000 starships, I could take up 1,000 people. Even going point to point, where I'm going like from New York to London or Tokyo in half an hour, going to passenger flight, that will be in the 1930s. So we'll be paying for that ride in bulk in the 2030s, because it will actually be cheaper than the regular plane to do that. But they'll prove it first with air cargo before they do that. And then going to the moon, which would only be a few days to travel, that will be something that everyone can do. So that I think also will be 2030s in some volume, that they'll go to the moon. And some people think, oh, why go to the moon? I think just for the adventure of like, holy crap, I could actually afford to go to the moon. I can become like Neil Armstrong and do that. It becomes
yeah.
so affordable with the new capabilities, people will do that. And then after that, go to Mars. And then, even if I'm like, I make YouTube videos and stuff like that, make some content, people doing those first things, if you do social media, you say, hey, look at me, I'm doing my selfies and my videos in orbit and on the moon and on Mars. I think that will be a big part of, you know, conquering and exploring space should be a great adventure. It will be hugely entertaining. So I think that
That's great. Well, I think Jackie, I think Brian just answered your question about stopping by the moon. So yes, so this is possible. So there's a question from Larry. Are there rules controlling the use of space for military purposes?
Yeah, there are treaties that you're not supposed to put weapons up in space. But again, like I said, if it's speed and kinetic energy, I can put something. If I put up um, a metal bowling ball, it's not really a weapon. It's got no explosives in it. But the fact that I'm traveling at 30 times the speed of sound because I'm in orbit means if I shove
Mm,
it out the door, it's a very powerful weapon, right? So,
yep.
just releasing stuff. So it's a matter of definition. I don't need to put up something because just going fast, just like when they flew the planes into the World Trade Center, right? If I fly something at really high speed, it's a very powerful weapon. So it's just a definition of kinetic energy and stuff like that.
Okay. Um, so Meng actually wanted to clarify his question earlier. He said the paper he was referring to that he read about the nuclear chaos, the nuclear weapon that creates chaos. He meant it that it was referring to using nuclear weapons for even disrupting a few satellites to knock out most of the satellites
Mhm.
through a domino effect of debris.
Right.
So
Okay.
then, yeah, so
Yeah.
that's what he was referring to.
Okay. So yeah, you can do that. You can do EMPs, electromagnetic pulses to wreck all the electronics if you haven't hardened your satellite. Causing a
Mm,
bunch of debris would be a big problem. And they think, oh, well, there's all these debris. But the thing is, if I can, let's say you wreck a thousand, let's say you wreck all the satellites, right?
mm,
42,000, you put up a bunch of weapons, you blew them up, you took out all the satellites, they're all in pieces now, right? Because I have all this launch capability, I can make a hardened starship that would then, be able to resist the impact and do stuff, and then, make some kind of like um, carbon mesh thing to catch a bunch of the stuff, and some kind of like bulletproof Kevlar type things that could catch these high speed objects and stuff like that. So because I have a lot of launch capabilities, I can clean it up. I can just
mm,
it would take time. It would be, a very big disruption and annoyance. It would crash the markets and all that kind of stuff. But because I can just clean it up and then relaunch, then that I can make the problem go away because I'm so capable, right?
mm,
So, and then the other thing would be that if you're launching a weapon up there and I have all the satellites and I have all the starships, I could say you're a troublemaker. You're going to try and
mm,
launch something that's going to wreck things because I know that you're a troublemaker. I can then say I can detect your launch because I'm watching everything around the planet, and then I can say,
mm,
okay, you're launching something I don't want. I can fly a starship overhead or one of my big satellites with a bunch of stuff loaded in it. I can release a bunch of ball bearings. Everything in several kilometers to square miles gets wrecked. So no planes, no drones, no anything, missiles go in the air. Anything I don't
mm,
want to fly gets destroyed, right? Because
mm,
you own the high ground. When you see everything, you know when someone's doing stuff. I can watch you preparing to launch something. I can detect that it's got nuclear material in it. And then I just say, that ain't going. I'm
mm.
shutting you down. You're not flying anywhere, right? That goes to the utter
Wow.
domination of if I have the high ground where I can see everything and I can launch and put down anything, that means my no-fly zone means you don't fly. You don't fly a
I
missile,
see.
you don't fly a drone, you don't fly anything, right? So don't
But
cause trouble.
somebody needs to govern that, right? I mean, so the question Meng has is actually, are there any defenses? So basically you're saying the defense is really basically no fly zone, right? Just trying to make sure you block them from being a troublemaker. But can anybody just come in and say, well, or do they have to go through the United Nations to get voted that yes, it's okay? Or
I'm saying there's no
yeah.
negotiation that the US
Mm,
doesn't want. The US and
mm,
SpaceX will have complete domination, and once you have like in 2 years, they already have domination now because our stealth fighters and all this stuff, that people who think that there's some kind of like equality or that China had a chance, they're wrong. Okay.
mm,
I'm sorry, that's just the way it is. So if once they have this capability, because I can put up all these satellites, I can watch everything. There
mm,
is there again, it goes to there's no ambiguity about who has full control. right?
mm,
And then whatever
mm,
negotiation you have, you say, you who have full control, you have starships, I want to negotiate something. And then the US side says, okay, I feel like doing this or I don't feel like doing that, but I don't have to do anything. I don't have to listen to anything that you say at all because I have total control,
mm,
right?
mm,
So that goes to there's no geopolitical ambiguity. There's no thinking, okay, you're number one and I'm a close number two, and then maybe no. It's like I'm number one and I'm 100 times more stuff than you. Like I said, we go from whatever to a million times. SpaceX has already gone to 20 times more than what anyone else had. And the reason that there are another 20% of satellites is because they chose to launch them, because they wanted the money
mm,
to launch them, right?
mm,
So when they go from that 20 times ahead to 1,000, a million times ahead, then it's like, it's like, was there a question before Airbus of like, I flew a 747 or I didn't fly, right?
mm,
I fly SpaceX or I don't fly, right?
mm,
I use their satellites or I don't, right? But
mm,
there's no like someone else being close. There's no one
mm,
else close,
mm.
which
So,
it simplifies things.
mm,
People can say, oh, but now I have to. You always had to do that, right? Because the U.S. military capability is way ahead. If you just looked at it honestly, you say, yeah, you can kill some people, but you actually would lose if you actually stood up to that military capability.
okay. Meng, I actually allowed you to enable your speaker if you want to unmute yourself. You can ask the next question yourself. Seems like Meng is very interested in this topic. So,
Mhm.
Meng, would you like to ask the question yourself, or you
I
want me
can,
to read your question?
I can read something. Sorry, no mic on the video. So he says he doesn't make a video. So Israel spent $1 billion Iron Dome
Oh,
against $10 million of Iranian missiles per round of attack. If I have insane amounts of wealth, and I'm saying this is going to trillions and trillions of dollars, right? Any kind of I paid blah to destroy your thing, I if I have enough money, I can do that trade, even if it's more, right?
mm,
So it's not good to spend more than the other person did, but it's not a showstopper. The US
mm,
spend $1 trillion a year on the military, right? So not like they're not blowing money to do something. The fact that they have to, blow on, they what $200 billion in Ukraine, right? There's like money is nothing, and they're just like burning it up in order to get their goals, right? So the fact that they wasted $1 billion is kind of like I guess it's Tuesday. So sorry about that. Larry saying the military talk is depressing, but I'm just saying that the benefits to mankind is everyone can be rich. We can get everything we want. We can go anywhere in the solar system. So that's the benefit. The grand adventure is that we can have the Star Trek future, right? Where we're going all over the solar system and can go out and we can see everything in the galaxy, right? So the positive future is that we will colonize everything. Everyone can have a million times more money. Everyone can be billionaire. If everyone has a gigafactory with 10,000 Tesla bots and their own starship, right? It's like everyone's as rich as Elon in the future, right? Because they have all that capability. And there's no like, oh, well, how can we have all that? It's because we'll be on, 1,000 mini worlds in our solar system and mining all the asteroids to do stuff. And it's like, oh, well, one that causes pollution, it'll be not in the Earth's atmosphere. It'll be elsewhere in the solar system. So
mm,
pollution goes away. Um, Lack of resources goes away, right? We will have, the abundance of that Star Trek future, and there'll be no aliens to fight or whatever because they're not around, right? And we'll be able to look everywhere in the galaxy within, you know, possibly as early as 2060. We could start seeing millions of planets around other places. So the Star Trek future would be very quick. I only address the military thing is that goes away. We do not have the competition militarily anymore. It's basically like, you know, the US won, they already did win, but now it's like totally unambiguously, you know, anyone who tries to start something, um, violently is just going to lose really, really bad, really, really fast. Okay. Just like, oh, I can reconcile it. No, you can't. Can't do it. It won't work. Just that I can go into detail about why that is, and I've already explained some. But basically, the ambiguity of maybe someone can do something to whatever is incorrect. And
Mm.
I'm not saying that could be bad. I'm just saying this is the reality, and the fact that there is one unipower is a good, unambiguous thing. So long as we have people who are in control that are not going to abuse it, and hopefully that's the case.
All right, thank you. Any other questions?
Okay, so if that's it, then we can probably wrap up. So there will be a schedule of other Monte Jade events coming out shortly, probably posted on a website, and then we'll probably send out emails to notify people. I'll probably do another talk in the new year. So I thank everyone for
Absolutely.
attending, and this is recorded and will be posted um, on the Monte Jade YouTube channel as well as mine. So.
That's wonderful. And we will be sending out a survey. Would greatly appreciate if all of you can respond to the survey. The key thing is if you can give us feedback on what other topics that you may be interested to hear from Brian, that would be very helpful in structuring our program next year. Thank you,
Okay.
everyone. Have a great Friday, the rest of the weekend. Bye bye.
Bye-bye.